In the last video, we did an energy calculation for an even-numbered fatty acid. In this one, we're going to do it for an odd number of carbons for a fatty acid. Now, the reason this is a little bit different is because the last round of beta oxidation does not yield an acetyl-CoA. Instead, we have a 3-carbon molecule left at the end. That 3-carbon molecule is called propenyl-CoA. So we have a 3-carbon molecule called propenyl-CoA. Now, this is something we haven't actually seen yet. This 3-carbon propenyl-CoA needs to be converted to succinyl-CoA, which we've seen before. We have seen this before. Succinyl-CoA is an intermediate in the TCA cycle, which can yield us some energy. Well, if it goes through the Krebs cycle, of course. So what we need to do is we need to take propenyl-CoA and convert it all the way to succinyl-CoA. So that process requires a few things. First and foremost, propenyl-CoA is a 3-carbon molecule, while succinyl-CoA is a 4-carbon molecule. So propenyl-CoA, we need to add a carbon to it. So that's going to cost us, that's going to actually, not cost us, we're going to add a carbon dioxide to propenyl-CoA. And adding a carbon dioxide to, in a reaction to a particular molecule is not a very simple task, because it's a gas typically. So it's going to cost us energy. It's going to cost us an ATP. So we're going to go from ATP to ADP. And the enzyme that actually does this is called propenyl-CoA carboxylase. And since it's a carboxylase, this enzyme will require biotin. Okay. Once we do that, we create a methylmalonyl-CoA, which is a 4-carbon molecule that is then converted into succinyl-CoA, and the enzyme that does that is called methylmalonyl-CoA mutase. So now, once we have the succinyl-CoA, where does this go? Well, we've answered that already. It goes to the TCA cycle. When it goes to the TCA cycle, what does it give us? The succinyl-CoA will give us everything that's produced after it. So what we'll get from this, we'll get 1 GTP, we'll get 1 FADH2, and 1 NADH. Okay, so once we put succinyl-CoA into the TCA cycle, it'll react all the way until it's converted back into oxaloacetate, which is what we started with, right? So in that process, we're going to get a GTP, FADH2, and NADH. If you don't believe me, go back through and watch the TCA cycle videos to refresh your memory. So let's do the example. If we had a 19-carbon fatty acid, what would happen? How would we calculate the amount of energy we get from it? So first and foremost, it's a fatty acid, so we need to convert it into an acyl-CoA to activate it. So that's going to cost us 2 ATP. Then we can go through beta oxidation. So beta oxidation, we clip off 2 carbons at a time. 1, 2, 3, 4, 5, 6, 7, 8. 8 rounds, and then we're left with this 3 carbons here. Okay, so we have 8 rounds of beta oxidation. So we have 8 cycles of beta oxidation that we're going to consider. And then how many acetyl-CoAs do we make? 1, 2, 3, 4, 5, 6, 7, 8 acetyl-CoAs. And then right here we have 1 propenyl-CoA. So now let's figure this all out through this equation that I've written here. Okay, so we have a 19-carbon acyl-CoA going through 8 cycles of beta oxidation, so it's going to require each one of these rounds will require one of each of these things we have here: coenzyme A, NAD+, and FAD. So these NAD pluses and FADs will be converted into NADHs and FADH2s. We'll have 8 of each of those. How many acetyl-CoAs do we get? Well, when we underwent 8 rounds, we had 8 acetyl-CoAs, and then we have 1 propenyl-CoA. So these things go to the electron transport chain, right, to be reoxidized. So we'll just count those here as 8 NADHs and 8 FADH2s that we'll add to everything else in just a moment. These acetyl-CoAs go to the TCA cycle, right? The Krebs cycle. And of course, each round, 3 NADHs, 1 FADH2, 1 GTP. And that's for 1 acetyl-CoA. There's 8 of them that we have here. So we're going to multiply each of these numbers by 8, and we get 24 NADHs, 8 FADH2s, and 8 GTPs. So now where does this propionyl-CoA go? Well, we just said that it has to be converted into succinyl-CoA. That's going to cost us 1 ATP, right? And then the succinyl-CoA goes to the TCA cycle, where it gives us 1 NADH, 1 FADH2, and 1 GTP. So now we're going to add up all these values. So the total number of NADHs we get, we have 24 plus 1 plus 8, which is 33. So 33 NADHs. And we have 17 FADH2s and 9 GTPs. If you multiply all those values out, we get 82.5, 25.5, and 9. If you add all those values up, you gross 117 ATP. Now, we net 114 ATP. Why is that? Well, we subtracted 2 for activation because we started off with a fatty acid, right? I told you we started off with a fatty acid, not an acyl-CoA. So we have to make sure that we take into this ATP into account. I mentioned it in the last video. You wouldn't have to subtract this 2 ATP here if you were calculating the amount of energy you would get from an acyl-CoA. Okay, but that still would leave us with 115 ATP. We also subtracted 1 from going from propionyl-CoA to succinyl-CoA. Right, that process costed us 1 ATP. So we net 114 ATP overall. If I had asked you for a 19 carbon acyl-CoA instead, the net would have been how much? Well, it would have been 116 ATP, right? Because we wouldn't have to subtract this the 2 ATP for activation, but we would still have to convert that last product, that 3 carbon molecule, that propionyl-CoA, into succinyl-CoA. That would still have to happen. So we'd still have to subtract 1 ATP to net 116 ATP. But in any case, I hope that was helpful, and thank you for watching.